I want to start with a question today that feels pretty simple on the surface, but it's actually kind of terrifying when you really think about it.
Oh, setting the stakes high early. I like it.
Well, think about how you make a really big decision, like taking a new job, or, I don't know, buying a house, or even just deciding to trust a new friend. How do you actually do it?
Right.
Do you pull out a spreadsheet, weigh all the variables, calculate the exact probability of success, or do you just feel it?
The famous gut feeling.
Exactly, the gut feeling. And for a long time, I definitely thought relying on my gut was a weakness. Like I was just being lazy because I didn't want to do the math.
Yeah, that's a very common assumption.
But today, we're doing a deep dive into some research that suggests that gut feeling might actually be a high-speed supercomputer, one that's processing data you didn't even know you had.
It really is fascinating. We are looking at the tension between heuristics, which are those mental shortcuts we all use, and formal logic. And it gets even more complicated because we aren't just talking about human brains today.
No, we are not.
We are also looking at how scientists are actively trying to teach artificial intelligence to tell the difference between a good argument and a bad one.
Which, it turns out, is really, really hard to do.
It is the ultimate test right now. Can we teach a machine to spot a lie or spot bad logic out in the wild?
So we have a really fascinating doubleheader of sources today to unpack all of this. First up, we have an analysis from Portland State University called Heuristics in Decision Making. And this is the one that really defends our human shortcuts.
Right. And to balance that out, we have a very technical paper from a team at USC and Armazeus Science and Technology. It's titled Robust and Explainable Identification of Logical Fallacies in Natural Language Arguments.
Which is really just a highly academic way of saying how to teach a robot to call nonsense on an internet comment.
Essentially, yes.
Yeah.
That is exactly what they're trying to do.
So our mission today is to unpack this black box of decision making. We're going to validate your intuition, catalog the logical traps that mess up our communication, and see if computers can actually learn to spot flawed arguments better than we can.
Well, let's get into it.
So let's start with the human side of things. The Portland State paper sets up this sort of historical battle between the old view and the new view of decision making. The old view is something called rational decision theory.
Yes, and this is the view that absolutely dominated economics and management literature for decades.
Right.
The whole idea is based on this concept of the rational man. It was always a man in the literature back then.
Of course.
But this theoretical person is basically an optimizer. Before taking any action, this person identifies every possible option, calculates every single possible outcome, assigns a numerical value to each one, and then just picks the mathematical winner.
Which sounds great on paper. It sounds incredibly responsible. But the Portland State paper argues that if you actually tried to live your life like that, you'd be completely paralyzed.
Oh, you'd never make it out the front door in the morning.
You'd just be standing in the cereal aisle forever.
Exactly. The paper makes a really crucial point here. Rational decision theory assumes you have unlimited time, unlimited computing power in your brain, and perfect information.
Which nobody has.
Right. In the real world, what the researchers call naturalistic settings, you have absolutely none of those things. Time is always short, the data is usually messy or incomplete, and the stakes are often very high.
So if you try to be perfectly rational in a chaotic environment, you just fail.
You do, and that is where the paper argues that heuristics, these mental shortcuts we take, they aren't bugs in our cognitive software. They were once seen as inferior or irrational, but recent research argues they are highly efficient adaptations. They are features.
But wait, when I hear the word shortcut, my brain immediately thinks of laziness. Skipping the reading and just skimming the summary.
That's the common misconception, yeah. But think about it this way. Efficiency is largely about knowing what information to safely ignore.
Okay, that makes sense.
The paper describes something called cognitive maps, and this is really the core of how our intuition actually works.
Cognitive maps. It sounds a little abstract. Is this like a memory palace technique?
Not exactly. It's more about latent learning, hidden learning. Imagine you drive the exact same route to work every single day.
Okay.
You aren't actively trying to memorize the potholes or the timing of the traffic lights or where the speed traps are, but your brain is passively recording all of it anyway.
Just running in the background.
Exactly. You are building a map of what causes what. Smoke leads to fire. Red brake lights 3 cars ahead mean traffic is stopping abruptly.
So you have this massive library of patterns just stored up.
Correct. And when you are forced to make a split-second decision, You do not sit there and calculate probabilities. You use what the paper calls the recognition primed decision model, or RPD.
RPD. Let's really break that down because I think this validates a lot of people listening who might think they're just guessing half the time at work. It's not actually guessing, is it?
No, it is definitely not guessing. It's a very specific, highly evolved three-step process.
Okay, what's step one?
Step one is situation assessment. You look at the chaos right in front of you. So maybe you're a firefighter looking at a burning building or a manager looking at a sudden supply chain collapse.
Right, taking in the scene.
Then step two is recognition. Your brain instantly scans that cognitive map we just talked about and finds a match. It basically says, hey, I have seen this pattern before.
Okay, so you recognize the situation. But step three is the part that really blew my mind in the reading. Because step three isn't just acting, it's mental simulation.
Yeah, this is arguably the coolest part of human cognition. Before you move a single muscle, you run a simulation, you play a little movie forward in your head, you ask yourself, if I take this specific action, what happens next?
And this all happens in, what, milliseconds?
Faster than you can blink. And if the movie in your head has a good ending, you act. But if the simulation ends in disaster, you tweak the plan and run a new simulation.
So when that firefighter suddenly shouts for everyone to get out because the roof is about to collapse, he hasn't done the math on the structural integrity of wooden beams.
No, he ran a lightning-fast simulation based on a pattern he recognized. Maybe it was the specific color of the smoke or the sound the wood was making, and the simulation said the outcome is death. So he acted. That is insight.
The sudden perception of a useful relationship.
Exactly.
And the paper mentions this is surprisingly common in business settings, too, not just emergencies.
It is. They cite statistics showing that 32% of managers rely primarily on this intuitive RPD model. And interestingly, for critical tasks like hiring, safety issues, or performance appraisals, that number jumps to 40%.
Wow. So the big takeaway from this first source is basically to trust your gut, because your gut is actually a sophisticated simulator built on years of hidden data.
Trust your gut in the right context. And
Yeah.
that is the massive but coming our way.
Right. Because the exact same mental system that saves you from a burning building might completely destroy you in a debate.
Exactly. Heuristics are amazing for physical survival. They're great for navigating patterns we've seen 1,000 times before. But when we try to apply those exact same shortcuts to complex, abstract arguments, that is when they hurtle into logical fallacies.
Which perfectly transitions us to our second source from USC. This paper is entirely focused on informal fallacies. Now, I know there's a difference between formal and informal fallacies. What is the quick distinction there?
A formal fallacy is basically a math error in language. For example, if you say, all dogs are animals, this cat is an animal, therefore this cat is a dog.
Right, the structure itself is just broken.
Exactly. The logic simply does not compute, and a computer can spot that structural error very easily. But an informal fallacy is much trickier.
Because the grammar is fine.
The grammar is perfect, the structure looks completely sound, but the actual content is cheating. It's an error in reasoning. It's sort of a linguistic optical illusion.
The paper breaks these down into a taxonomy, a classification system of 4 broad categories. And I want to walk through a few of the specific examples I use because once you have a name for these, you start seeing them everywhere.
Oh, absolutely. It is the default language of the internet.
Let's start with the fallacy of relevance.
This is when your brain's shortcut kicks in and says, I really don't have time to analyze this complex argument, so I'm just going to analyze the person saying it.
The classic ad hominem attack.
Right. The paper gives a great example. It says, Boris is not qualified to make suggestions because as an ex-convict, he would always take the criminal side.
Now, if I am using my RPD, my pattern matching brain, I hear the word convict, and my cognitive map immediately links that to untrustworthy, pattern matched, argument rejected.
Exactly. Your heuristic worked perfectly, but your logic failed completely. Because, logically speaking, Boris's criminal record has absolutely zero bearing on whether his specific suggestion for, say, a new filing system is a good idea or a bad idea. You attacked the source, not the claim.
Another really common one in this relevance category is the ad populum fallacy. The example was, aliens must exist because millions of people believe in them.
And again, you see the heuristic at work. The mental shortcut says, there is safety in numbers. If everyone else believes it, it is probably true. That is a literal survival mechanism for humans.
But logically, the number of people who believe something has absolutely no impact on the actual existence of extraterrestrials.
Exactly.
Okay, then we have the second category, fallacies of defective induction. This includes things like false causality.
Right, so the example is, the temperature dropped and then I got a terrible headache. Therefore, the cold weather caused my headache.
I feel like our brains are hardwired to do this one. We absolutely hate coincidences. We desperately want A to cause B.
We crave narrative. It's that cognitive map again. We want to draw a straight line between events so we can predict them the next time. But in reality, those two events are often totally unconnected.
They also mention the false dilemma in this category.
Oh, yes. Subscribe to our premium service or get stuck with terrible cable forever.
Right, pretending there are only two options when there are actually dozens. And then the third category is the fallacy of presumption, which includes unwarranted assumptions.
Like circular reasoning. The paper used the example, quinoa is delicious because it tastes good.
You're just restating the premise.
Exactly. You aren't actually providing any supporting evidence. You're just looping the argument back on itself.
And then there's the fourth category, the fallacy of ambiguity. And this is the one that really trips up the artificial intelligence, right?
This is by far the hardest one for machines. The paper uses an equivocation example.
Oh, the freeze joke.
Right. The police asked me to freeze, but it was a hot day, so I ran.
It's just a solid dad joke.
It is. And the reason you laugh is because your human brain instantly understands that the word freeze has two completely different definitions depending on the context. One means to stop moving, the other means to literally turn to ice. You can hold both meanings in your head at once and see the absurdity.
But a computer can't do that.
Not naturally, no. A computer just sees the text string F-R-E-E-Z-E. It doesn't inherently know which definition applies to a police encounter versus a weather report. It gets completely lost in the ambiguity of human language.
And that brings us to the core problem the USC researchers are actually trying to solve.
Yeah.
Because we are drowning in these fallacies online right now. Misinformation, propaganda, it is all just weaponized bad logic.
It's everywhere.
And it's no longer possible for humans to fact-check or logic-check every single argument manually. We need AI to help us flag this stuff.
But as the freeze example shows, teaching a machine to truly understand context is incredibly difficult. Logic isn't just a set of rigid mathematical rules, it actually requires common sense knowledge.
Which AI is notoriously terrible at.
Historically, yes.
So the paper proposes 3 different technical solutions to teach an AI to spot these logic traps. And what I really loved about this part of the reading is that the engineering solutions they came up with actually mirror the human psychology we were just talking about.
They really do. It's almost like looking in a digital mirror.
Let's walk through them. The first solution they tested is called instance-based reasoning, or IBR.
Right. So think of this like the dynamic between a junior lawyer and a senior lawyer. A junior lawyer might try to memorize all the specific statutes and the rigid rules of law, but a senior lawyer relies on case law. They look at a new case and say, oh, this looks structurally exactly like Smith v. Jones from 1998.
So instance-based reasoning is basically the AI looking for precedents.
Exactly. When the AI is fed a new argument, it uses a component called a retriever to instantly scan a massive database of old labeled arguments. It looks for a match.
How does that work in practice?
Well, it might look at a new argument like, everyone is buying the new smartphone, so it must be the best one. And the AI says, structurally, this looks identical to this old argument I have on file that says, everyone believes in ghosts, so they might be real.
And since that ghost argument was previously labeled as an ad populum fallacy, the AI just slaps the exact same label on the smartphone argument.
Correct. It uses an adapter to filter the comparison and a classifier to make the final call. And here's the real kicker from the study. This instance-based method actually performed the best in their experiments.
Which is absolutely fascinating because that is literally the human RPD model. It is just pattern matching.
It really is. It turns out the best way to make a computer appear logical is to make it mimic human memory and experience. It isn't deducing the fundamental truth from first principles. It's literally just remembering that it has seen this specific flavor of nonsense before.
But there has to be a limit there, right?
Yeah.
Like, if the AI hasn't seen a specific structural example before, it's just stuck.
Exactly. It can't improvise. It needs a massive library of past examples to work. So that leads to solution number 2, which is knowledge injection.
Knowledge injection. That sounds very sci-fi.
It does. They used an approach called KBERT.
Yeah.
And essentially, they tried to hard code common sense into the machine. They injected something called a common sense knowledge graph into the AI.
How do you inject common sense? What does that actually look like?
The best way to visualize it is to imagine reading a sentence. But every single word in that sentence has a little sticky note attached to it explaining what the word means in various contexts.
Okay.
So going back to the freeze joke, the knowledge graph would create a sentence tree. It would attach a note to the word police saying law enforcement, and a note to freeze saying, in the context of law enforcement, this implies a command to stop moving.
So it forces the AI to actively read the context.
That is the theory, yes. It helps clear up ambiguity. But they ran into a very human problem during testing information overload.
The paper called this the branching factor, right?
Yes, the branching factor. If you add too many sticky notes to a sentence, if you explain that police wear uniforms and carry badges and drive cars with sirens, suddenly the AI completely loses the thread of the original argument. It just becomes noise.
It's paralysis by analysis, which is the exact thing our human heuristics are designed to prevent us from doing.
Precisely. If you give an AI too much context, it gets confused and paralyzed. Just like that perfectly rational man we talked about at the very beginning of the deep dive.
That is wild. Okay, so what was solution 3?
Prototype-based reasoning, or PBR.
Right.
This one is a bit more abstract. Instead of looking for any similar past argument, like in the first method, the AI tries to match the new argument to a prototype. Basically, an ideal representative example of a specific fallacy.
Like the textbook definition of a logical trap.
Exactly. But the researchers found something really nuanced and interesting here. The AI actually learned much better when they used negative prototypes.
Negative prototypes, meaning what?
Meaning the AI learned what a fallacy was by looking at clear examples of what it wasn't. It's like teaching a toddler what a cat is. Sometimes it is incredibly helpful to point at a dog and say, not a cat. It helps define the strict boundaries of the concept.
That makes a lot of sense. It helps the AI separate, say, really tough, aggressive argument from an actually logically flawed one.
Exactly.
Now, they didn't just throw the AI into the deep end with all this. They used something called curriculum learning, which, as I read it, is literally just sending the AI to school.
It is. You don't teach a first grader calculus on day one. You start with 1 + 1. So the researchers used forward curriculum learning.
So what was step 1 for the AI?
Step 1 was just binary detection. A simple yes or no. They just asked the AI, is there a fallacy anywhere in this sentence? Don't worry about which one it is, just spot the error.
Okay, and step 2?
Step 2 moved to coarse-grained classes. Basically asking, is this a relevance issue or is it an ambiguity issue? Broad categories.
And finally,
Fine-grained detection. Is this specifically an ad hominem attack? And the data clearly showed that learning in this strict order, building up the complexity step by step, made the AI significantly smarter and more accurate on the really hard tasks.
so just putting this all together for a second, we are building machines that use pattern matching, just like we do. They struggle with too much context, just like we do. And they learn better when you teach them simply at first, just like we do.
We are quite literally building them in our own cognitive image.
So the big question, does it work? Do we have a universal, foolproof logic detector now?
No, we do not. And the reason why is arguably the most important takeaway from this entire deep dive.
Lay on me.
They took this AI, which was thoroughly trained on spotting general logical fallacies, and they decided to test it on a very specific real-world topic. They used the climate change news data set.
The logic climate data set.
Right. And the AI failed. Its performance dropped significantly.
But why? If it knows exactly what a false cause looks like structurally, why can't it spot one in an article about climate change?
Because you cannot neatly separate logic from truth. To understand why an argument about climate change is a logical fallacy, you actually have to understand climate science.
Give me an example of that.
Okay, let's say I make the argument, carbon dioxide is food for plants. Therefore, putting more carbon dioxide into the atmosphere is good for the Earth.
Structurally, that looks like a clean, logical sentence. A equals B. B is good, therefore A is good.
Exactly. To know that it is actually a fallacy of defective induction, the AI needs domain knowledge. It needs to know that while CO2 is indeed plant food, too much of it causes a greenhouse effect that ultimately kills the plants. You can't just check the grammar of the argument, you have to check the facts.
Wow, that is a massive hurdle. That means we can't just build one master logic bot to rule the internet. We would need a logic bot that is also a world-class expert in medicine and international law and quantum physics.
Correct. Context is everything. And there's one final, slightly darker detail from this study that really highlights this.
Oh, I know what you're going to say.
The researchers ran out of data. There simply aren't enough perfectly labeled lists of logical fallacies in the world to train these massive AI models.
So how did they fill the gap?
Well, they used data augmentation. They swapped in synonyms to create new sentences. But they also deliberately imported propaganda datasets.
They trained the logic-checking AI using propaganda.
They had to, because if you analyze the underlying structure of propaganda, it is almost identical to the structure of logical fallacies. Propaganda is ad hominem. It is false dilemma. It is the appeal to emotion.
That's heavy. It really implies that bad logic isn't just an accident or a slip of the tongue. It's a weapon.
It is a fundamental feature of how human beings manipulate each other.
And honestly, it raises an incredibly provocative question for me about what these machines are actually learning. Think about it. If the absolute best AI model, the instance-based reasoning one learns by mimicking past arguments.
Right. If it learns what is true by looking at a massive database of how humans have argued in the past.
Are they actually learning logic? Or are they just learning to imitate our very flawed history of arguing with each other?
It's a great question. Are they becoming truly rational, or are they just becoming really, really convincing rhetoricians?
That is the ghost in the machine right there.
It absolutely is.
So let's bring this all back down to reality. To the listener who have to go make a tough decision today or read the news today. We started this deep dive by asking, gut feeling or logic?
And the answer, unsurprisingly, is both. But you really have to know which gear you are in.
The Portland State paper was pretty clear. Trust your heuristics when you actually have experience.
Yes. If you are an expert, if you are that seasoned firefighter, or you're doing a specific job you have done every day for 10 years, trust your RPD. Your brain has built a highly accurate cognitive map. Use it. Do not overthink it.
But when you step out of your lane...
Right. When you are reading a news article about a complex scientific topic you don't fully understand, or you're listening to a politician who is actively trying to scare you, that is not the time for the gut feeling.
That is the time to manually pause the simulation.
Check the code. Look out for the ad hominem attacks. Watch out for the freeze trick, the equivocation.
Because if we don't catch those fallacies ourselves, the machines definitely aren't ready to catch them all for us yet.
Not yet. We are still very much on our own out there.
Well, on that comforting note, we are going to wrap up. Thank you for letting us take up a little space in your cognitive map today.